Exam okay, easy? Boleh lah.
I think so.
I think so. I saw the marks is quite okay lah. Very good lah actually. So okay. Anyway, don't forget next week is your quiz. Your quiz would be at 4:30 p.m. next Thursday. It's not during your lab time. So every group will be taking the same quiz next week. So 4:30 p.m. You will have to take the quiz at Philip. Okay. Yeah.
Oh, the quiz cover.
So the quiz I will be posting the details on the dekat you punya Philip nanti. Alright, but it's next week. You tengok you punya schedule pun it's next week. Okay. So if no questions, I'll proceed with the lecture. So I hope you can see my slide, yeah? Alright, you can see my slide. So our lecture today will be a short, it's short because it's very simple. So the topic today will be on searching algorithms lah. Basically, how you search in a array. So you can either search in an array or a linked list. But the implementation, we're going to look at in an array. Okay. So we're going to look at the concept of linear and binary search. All right. So linear is very simple. It's just like how you would process an array. Binary search is based on the concept of divide and conquer. All right. And then we're going to look at how you implement these two in C++, all right? And then we're going to look at the efficiency of the search algorithm. And finally, you become aware only on the concept of lower bound for search algorithms, all right? So for search algorithm, what you want to search is what we call as a key, all right? You're going to find this key in the set of data, all right? So there's two types, sequential and binary search. Binary search can only be performed on sorted list. So what does mean sorted list means 1, 2, 3, 4, 5, 6, 7, 8. That is sorted. Unsorted would be 1, 5, 8, 9, 7, 100. That is unsorted list. Okay. Sequential search can be performed on both sorted and unsorted lists. So now we're going to look at sequential search. All right. So it's also known as a linear search. All right. Both method is the same for both array and linked lists. So how is it performed? First, it compares the key element with each element in the array, right? So it will keep on repeating this process until it finds the value that you want to match against your key, whether the same value, all right? So if it finds the same value or it finds a match, then it will return true. Else it will return -1, means the item is not found. So here is an example whereby you want to find the value 20 inside this set of number. So you compare with number in index 0, and then 1, and then 2, and then 3. So you compare in every index until you reach index 6, whereby you find a match, and then you return the value that you return true. All right. Sometimes you will, apart from returning true, you also return the location to where the match is found. So this is the code for sequential search. It receives the item, basically the item that you want to find inside the array. Integer location here is the index when a match is found. Found here is a Boolean function initialized to false because you haven't found the item yet. So from location 0, whereby the location must be less than the length, increase the location by 1. So list is the array. If the value inside the location is the same as the item that you want to find, then variable found will be set to true, break. If found, then you return the location to the location of where the item is found. Else you return -1. Okay, simple. Any question?
So far, no.
No, okay, quite easy. So, sequential search, basically, you're going to search in every one of the index. Therefore, the complexity will be O(n), because it has to make n number of comparisons. Best case scenario, whatever item that you want to find, you immediately find it, whereby it becomes O1 algorithm. So the first item that you search, the first item that you find lah. Worst case scenario, it makes up to n number of comparison whereby it is ON algorithm. Okay. So it works well for small array and unsorted arrays. It's inefficient for large array because you have to go and find the item in every single index. All right. If the array is sorted, then it's best to use the binary search technique. Okay. Now we're going to look at binary search technique. Excuse me. All right. So in binary search technique, it can be performed only on ordered lists. Okay, that's number one. It can only be performed on ordered lists. And then it's based on the divide and conquer strategy. All right. Normally, ordered list is sorted in ascending order. All right. So the key steps here, if the key is less than the middle element inside the array, all right, then you need to continue to search for the key in the first half of the array. Okay. You see, the difference between sequential search is that now the process of finding is cut into two. If it's less than middle, you only look at the first half. Okay. And then you find until you keep on dividing that first half until you find the number. Okay. Whereas linear search, you have to look in every data or element inside the array. That's the difference. Now, if this is performed, okay, if this is not the case, then if the key is equal to the middle element, then you find a match. Else, you're going to look at the next second half of the array. Okay, so basically, this array, you cut it into half. If the key is less than the value in the middle, you search in the left side. Else, you search in the right side. And then you keep on cutting the right side. Okay. Now, so basically, that is how binary search is performed. You basically cut into half. If the value is less than the value in the middle, you go find in the left side. Else, you go find in the right side. And then this right side, you keep on cutting it and you keep on cutting it until you find the number. But never mind, we look at the algorithm straight away. So what you notice there, this is the item that you want to find. So this one best you write in paper. What is the value of the variable first? Last. So last is length minus 1. So if it's 10 number, that means the index is from 0 to 9, right? So that's why first is 0. Last would be, so this one, let me count how many values you have. The length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 now. So that means the last, the index will be 10 minus 1, which is 9. Okay. What is the value for the variable middle? All right. So the Boolean, if you find it, if you find it true lah. When you initialize it, it is false. So while first is not equivalent or less than last and not found yet, middle is first plus last divided by 2. All right. So 9 plus 0 divided by 2 is 4.5. In middle is an integer, therefore it becomes 4. Now, if least middle, which is 4 here, 16 here, is it the same as the item that you want to find? The item that you want to find is, what is the item that you want to find now? It is 23. Okay. Now, current is 16. Any questions so far? If you got question, better ask now. Otherwise, you memang cannot follow. No question, Then I proceed, Now.
So far, okay.
All right. Okay, now. Is 16, is 16 more than 23? No. So it goes to the else part, whereby first now is mid plus 1. So your value of first now is mid. What is mid? Mid is 4. 4 plus 1, it is 5. Okay. So you go back up, and then mid is first plus last divided by 2. Your value of first now is 5, last is 9. 9 plus 5 is how much? 14. 14 divided by 2, so your middle value now would be 7. So you see here, now it goes to the index 7. Okay. So the value in index 7 is 56. Now, is it the same as 23? No. Now, is 56 bigger than 23? Yes. So now last is mid minus 1. So last is mid minus 1, mid is 7. 7 minus 1, it is 6. Okay. So now we're looking at 6. Okay. Okay. So, okay, just for illustration purposes here, it's now M is 7 here. Okay. Now, your last now, because 56 is more than 23, okay, 56 is more than 23, your last will be mid minus 1. Okay. So, mid minus 1 would be your last value, which is 6. Okay. So, you go back up. What is the value for middle? Middle is first plus last. First is 5, last is 6. 6 plus 5 is 11, divided by 2, it is 5.5. So your value for middle would be 5. Okay. What is the value of 5? It is 23. Okay. So 23 is the same value as the item. Then you set found to true. If found is true, then you're going to return the middle value, which is 5. Okay, any questions? No question, yeah? So quite easy, just that you have to write it on paper. So this is another example. Okay, so this one you can go through by yourself, yeah? 0, 9. You divide by 2, so you get 4.5. So you take the 4. Okay, so the item that you want to find is this. Okay, these two is not, by the way, these two is not the same. This one is different. Okay, so here item is 63. Okay, so they want to find the value of 63. Okay, so divide by 2, value is 57. So 63 is bigger than 57. So it looks at this second part. All right, then this second part we cut, and then finally we will find the value. So this one you can try by yourself at home. All right, just to test you punya knowledge. So my recommendation is you write on paper the variable first, last, mid, find, and the current. Current is basically the value of the current of the middle. All right, the element within the middle. Okay, so you write it on paper and then you try on this example. So what is an ordered list? So an ordered list basically alphabetical or numerical order, usually sorted in an ascending order. All right, what are the operations that you can perform? You can see whether the list is empty, full, print the value inside the list, or clear the list. All right. So list, you can refer back to your lecture note on lecture 3. All right. So these are basically the operations on inside the list that you can perform. So there's so the most common one is to insert an item inside the list. All right. Okay. So to insert an item inside the list, all right, use an algorithm of binary search to find whether to find the place where the item is to be inserted. So you're going to use a binary search algorithm to find the place where you want to insert the item. The item is the item that you want to insert lah. Okay. So basically use binary search algorithm to find where you can put the item, your item. All right. If the item is already inside the list, then you tell the user, we cannot add in this item anymore because it's already inside the list. Else, you're going to use the function insert add to insert the item inside the list. So this is the coding for insert add. Okay, but I want to go to the full coding first because it's easier to understand the full coding rather than look at the small one, this particular function. All right. So here you see, this is basically same like your binary search. It's basically your binary search. Just that the difference here, you see, Okay, we go one by one. So here checks if the list is empty, then you're going to put in the item, you increase the length of the list by 1. Because it's currently 0, right? So when you put an item, then the length will increase lah, the length of the list, all right, by 1. If the length is same as the maximum size, then you cannot insert anything anymore inside list. So this is the binary search algorithm. So if you notice this binary search algorithm, right, it will keep on cutting. If you found the number, then that means the item is already inside the list. Okay. However, if you keep on finding, you think of the logic, you find, you cannot find, list is middle. So at the end of the day, they will keep on cutting the array, right? Okay, this one is, you assume that you haven't found the value. All right, you keep on cutting the array because you want to find the value. Now the item, because this is an ordered list. Okay, that means the item that you want to add must be bigger than the previous item lah. Okay, because it's ordered list. So if you haven't found the item, then list made the value there. See nampak the value there? List, this middle that you already cut, must be less than the item that you want to insert. Okay, then you increase the middle by 1. Okay, because the list mid must be less than the item that you want to add. Okay, so if this is 6, this is 7, mid plus plus goes to the next index inside the array. Next index inside the array, next index. Insert at the location here. Letak sini and the item. This middle already increased by 1, you know. Because here, if this is 6, this is 7. You want to add in this item, so it has to be the next index. That is accomplished by mid plus plus. So you go insert add, then we go to this function. So this location is actually the middle values now. This mid. Okay. Now, if location is less than 0 or location is bigger than the max size, then the position cannot be inserted because it's out of range. Okay. If length is more than max size, then that means the list is already full. Else, for I equivalent to length of the list, I is more than the location. All right, the middle here. Now this I is minus. Why? Because you want to move the element down. You want to add in the value, right? So you got to move the element down. So list I here is assigned to list I minus 1. So this will keep on repeating itself until I is less or equivalent to location. Okay. Only then, bila you dah shift things go down, when you things ready go move down, okay, then only you insert the item. So this is not inside the loop. This is outside the loop. Okay. Then only after that, finally, when you have insert the item, then you increase the length of the list. Because you add in new number, so the length from 5 will become 6 lah. Okay. Any questions? No questions, yeah?
So far, still digesting.
Okay. All right. So now we're going to look at the algorithm analysis for sequential search and binary search. So, okay. So this one, successful search is ON up till N numbers. Same with unsuccessful search. Binary search is O log 2N. All right. So for this concept is basically lower bound comparison. You just need to be aware lah. So basically it says sequential search is up to N, binary search is up till log 2N. So it wants to look at the efficiency of comparing the keys. All right. So here basically, if you see, if the list is sorted, SRH here, okay, because it has to look at every single item inside the list. All right. There it's written here, element XL. Then it has to be bigger or equivalent to log 2N plus 1. That means for comparison base, you can, the most efficient would be the binary search algorithm because it's log n. Okay. So this SRH, okay, must always so basically this one SRH has to be basically the most efficient would be binary search algorithm. All right, because SRH has to be bigger or equivalent. All right. Okay. So for this one here, for lower bound comparison, it's just basically you just need to be aware of. So what is SRHN? Yeah. So basically it is your lead sequential search. All right. Whereby let me see, whereby it was up till n. Okay. Okay. So any questions for searching? So actually it is quite short for searching. Hello, anyone? Any question?
No question, sir.
So far, no
Okay.
question
All
for
right.
me
Okay. Yeah.
at this
So I
stage.
think the lab one will be a little bit longer. Okay. So for next week, Monday, your class is on Monday, right?
Yes, sir.
Yeah, on Monday, yeah.
Monday no class, Gawai holidays next week. Is it Gawai? I forgot. But Monday is Wesak. Oh my God, sorry. Okay. Wesak holiday. Okay, so next week Wesak holidays. So there's no class next Monday. Okay. All right. So if no question, that's all for today. I'll be posting your marks by next week for your quiz and your midterm. Okay. All right. If there's no question, that's all for today.
Sir,
Okay. Bye everyone.
Sir, our next quiz is MCQ, is it?
Yeah. MCQ. Macam you punya quiz one.
Okay, thank you.
Thursday. All right. Okay. Bye.